Welcome to Holt Geometry. Today we're going to talk about geometric proof. This is lesson 2-6. Before we get into proofs, which we've been doing right along, today we're talking two columns, as we usually do. We're going to look at 4 new theorems. Okay? And none of these are going to come as a surprise to you. When you look at the first one, it's simply the linear pair theorem. If two angles form a linear pair, then they are supplementary. We know this, we learned it in chapter 1, but we're going to be using it a little more in this lesson, so I just want to point it out to you again. So if you're told angles form a linear pair, you can conclude they're supplementary, and you can write angle 1 plus angle 2 equals 180 degrees. If you're told they're supplementary, you can conclude that they form a linear pair. Works both ways. The congruent supplement theorem says if two angles are supplementary to the same angle, then the two angles are congruent. Notice angle A is the supplement of angle B because it's 180 degrees minus angle B, 100 degrees. Well, angle C is also a supplement of angle B because it's 180 minus 80 degrees. So if they're both supplements to the same angle, then you can say the angles are congruent. The third angle theorem, right angle congruence theorem, very straightforward, but we need to say it out loud. All right angles are congruent. So if you know both two angles are right angles, you can say they are congruent. You can use them in proof, okay? And as stating they're congruent. The reason you can is it's the right angle congruence theorem. And the final theorem, very similar to the congruent supplement theorem, is the congruent complement theorem. If two angles are complementary to the same angle, then the two angles are congruent. Notice both angle C and angle A are complementary to B because if you have 60 plus 30, you get 90. So angle C, the complement is 90 minus 30, 60 degrees. Angle A, the complement is 90 minus 30, 60 degrees. Both A and C complementary to B, so we can say A and C are congruent. So just things you might want to use in a proof. Now, how are these proofs going to work with geometry? Well, you're going to get something like this. You might get a picture. You'll do the same thing we've been doing right along. You'll have a given and you'll have a proof. And whatever the given is, it is the first thing you write under your statement column. And the reason you write it is, of course, that it is given. Okay? Then we're going to have to use this stuff to get to the proof thing, which will, of course, be the last statement you write. So we know B is the midpoint of AC, and you'll get pictures here a lot of times. If I looked at this piece of information, B is the midpoint of AC, and I see AC here, well, I would say that means that this is congruent to this. AB must be congruent to BC. And I would write that. AB is congruent to BC. And I know that because I'm given a midpoint, and that's the definition of midpoint, is the two halves are congruent. Now, I was also told that AB was congruent to EF, so I'll write that down in my proof. And the reason I know that is because it was given up here. So again, I'll write given. Now, if I look at what I've got here, AB congruent to BC, and here, AB with one tick mark congruent to EF, so I put one tick mark here too. I say, wow, okay, here's the link. Here's the link. And when you've got that link, if AB is congruent to both BC and EF, then we know that BC has to be congruent to EF, and that is the transitive property of congruence. So we look at our proofs and we just kind of fill in what we know, And we always look to the statement before that to see why we made that conclusion. So that should help a little bit as far as writing a two-column proof. You're just going to be pulling in all of the reasons that you know and look for them in the statement directly prior or in the two statements prior for that. And also you can look at, oh, that was given to me. Write down your givens. You know your first statement will be the given. Your last statement will be the proof. So now what if you've got a plan? You're going to see this in your homework too. What if you've got a plan and you need to write a two-column proof? So this is all you're given. You're given some information. You're asked to prove something. And they might give you a picture. Picture's not real helpful in this case, but we'll look at it. But they give you a plan. So if you've got a plan, you know exactly what you're going to do. So you always start, don't panic and say, I can't do this. You start right away with statements and reasons. And your first statement is always what you're given. Angle 1 and angle 2 are complementary. Angle 2 and angle 3 are complementary. I got 3 angles over here. I don't have any measures because all I know is they're complementary. But I'm given that. My reason is given. Now the plan, let's read our plan. The measures of complementary angles add to 90 degrees by definition. So you know what? I can say angle 1, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And I can say the measure of angle 2 plus the measure of angle 3 equals 90 degrees. And my reason is definition of complementary angles. So you're just using your plan. Use that. What does it say to do next? Use substitution to show the sums of both pairs are equal. Well, wow, they both equal 90 degrees. So I can take out the 90 and sub in this. So number 3 is going to be the measure of angle 1 plus the measure of angle 2. This one equals the measure of angle 2 plus the measure of angle 3. And it said use substitution. There's my reason. Substitution. I'm spelling that wrong. Substitution. Property of equality, because I'm using an equal sign there. Okay? Now, I use this. Now, it says use the subtraction property. So I'm going to do that next. Well, I see that here's the measure of angle 2, and here's the measure of angle 2. If I subtracted that from both sides, I would have, oops, that's 4, the measure of angle 1 equals the measure of angle 3, and that's just using my subtraction property of equality. So I use that. Now I'm going to use the definition of congruent angles. And I'm going to conclude this. Well, that's nice. That's what I wanted to conclude. I wanted to conclude angle 1 was congruent to angle 3. And it says definition of congruence. Remember, the definition of congruence says if angles are equal, they are congruent. So I can say definition of congruence. And that's always how you get from equal to congruent or congruent to equal. So there we go. We've used a plan and we have figured out how to do this. Now, remember, if you go to the back of your book in the appendix, you can find all of the postulates and theorems that we have been using, and those might be helpful to you if you've forgotten some things as you look for your reasons. But always, your reasons are going to be right up here. Just look at what happened from this step to this step, from this step to this step. You can see subtracting. You can see changing from equal to congruent, definition of congruent, subtraction. You can see, whoa, just slid this over here because they're both equal 90, substitution. So use what you know. Hope this is helpful, and have fun in class. See you in class.